Hello friends, today we will solve the 15th problem of this tutorial series on dynamic programming, which is matrix chain multiplication. And we will solve this problem in Coding Ninjas. But before we start understand the problem statement, let's do a quick refresher on what is a matrix and what is the meaning of matrix multiplication. So suppose I have got a matrix A in which the dimensions are given as 2 and 3. So by 2, it means that in this matrix A, there are 2 rows like here, and there are 3 columns, 1, 2, and 3. So 2 multiplied by 3 means that 2 rows and 3 columns. And I have put some random numbers here. So this actually represents a 2 by 3 matrix named as A. And now I have created a second matrix B, which dimensions as 3 by 2. Again, by 3, it means that there are 3 rows, and by 2, there are 2 columns. So here, again, we have got 2 matrices, A with 2 rows and 3 columns, and a second matrix B with 3 rows and 2 columns. Now, if we want to multiply these 2 matrices, the one thing which is very important is that if I want to do A multiplied by B, so it means that this condition is very important, that the number of columns here should be exactly same as the number of rows in the second one. So this is, if these are not matching, then we cannot multiply these 2 matrices. So the reason for this is that if we try to multiply, let's write the formula for the multiplication. So if I want to do a dot product for A multiplied by B, suppose I want the final product to be noted as C. So the dimensions of it would be the number of rows in matrix A and the number of columns in matrix B. So that's why I have written as 2 into 2. So 3 and 3 is the common term which has been removed, and this is the product. And the formula for this is that now we are going to have 2 by 2 array, right, like this one, right? So this would be the final output of the dot product of A and B. And the formula of the first cell would be 1 multiplied by 7 plus 2 multiplied by 9 plus 3 multiplied by 11. So let me write it down quickly. So 1 multiplied by 7 plus 2 multiplied by 9 plus 3 multiplied by 11. Similarly, for this second this cell, the formula would be again 1 multiplied by 8, 2 multiplied by 10, and 3 multiplied by 12. I mean, we need to add all these products just like this. So that's why I mentioned that for the dot product, it's very essential that the number of columns in the first matrix A should be exactly matching with the number of rows in the next in the second matrix B. Otherwise, we cannot end up with this formula. So let me quickly write down for all the 3 cells the formula and the values. So this is the formula for all the remaining cells for the product. So again, let's revise. For the first cell, it was 1 multiplied by 7 plus 2 multiplied by 9, 2 and 9, and 3 multiplied by 11. And similarly, for the second cell here, it was this row multiplied by this column, and add all of them. Similarly, for the next row, it was 4, 5, 6, the second row multiplied by this one, which comes here, this formula. And for this, again, 4, 5, 6 multiplied by 8, 10, and 12. And after doing all these products, this is the final values that we got for the final dot product of A multiplied by B, A dot product of B. So this was the basic formula for doing any dot product for 2 matrices. Now let's see that how many total number of operations that we have done while doing this multiplication. So if I count, so for first cell, it was 1, 2, and 3, right? So there were 3 products that we have done. Similarly, we have done 3 products for all the remaining 3 cells. So it was total, if I just total count, the total number of total operations that we have, operations or products that we have done, it's actually, there is 3 in one cell, so 3 multiplied by 4, so it would be 12. But in other words, we can also see that if there are like whatever the matrices are provided with different dimensions, the total operations can be also put it like 2 multiplied by 3 multiplied by 2. By 2, I means that 2 is the number of rows for matrix A, which is this. So this 2 came from this 2, and 3 is the common value, I mean the column of A and the number of rows for B. This 3 from here, and this 2 came from the number of columns in B. So this is the formula for the total number of operations that we have performed to get the dot product for 2 matrices, which is, again, if I just write it again as a formula, so it would be number of rows for A multiplied by, I mean the common column which is there, we can also put it as number of columns for A and number of columns of B. This is the formula for total number of operations. Now we'll see that what is the problem statement now, because we have got a good refresher for matrix and multiplication. So let's go back to the problem statement.